Okay, in this video we're going to be looking at alcohol. So alcohol is a very well known type of chemical. Everyone pretty much knows what alcohol is, even non-chemists. And there is actually a massive variety of uses for alcohol, not just for alcoholic drinks, but also for biofuels. So like E10, like in this picture here, has ethanol in it. It's quite a common organic solvent. And also it's a building block of a lot of different other substances like plastics, paints, explosives, textiles, cosmetics, just to name a few. So it's common to be used in chemical synthesis. Now the structure of an alcohol has a functional group which is a hydroxyl group, OH, which is known as a hydroxyl group, and that is attached to the hydrocarbon chain. As you can see in these diagrams below. We call these a functional group. Okay, any group attached would be called a functional group, and in this case it's a hydroxyl group for an alcohol. Now you can see here that there's three different ways that could be attached. For example, with a primary alcohol, these are the main ones we'll look at to start with, it's just attached straight to the carbon chain. And you can see R here. R is any alkyl group. So alkyl being an alkane group. So this could be, say, 3 carbons long, and then just OH on the end. So that's your primary alcohol. A secondary alcohol is attached to a carbon chain, but halfway along the carbon chain. So it's not on the end anymore, it's actually in the middle of the carbon chain there. And lastly, a tertiary alcohol is where it's attached to a carbon which is attached to 3 other carbon chains. These types of alcohols all have slightly differing reactions, so depending on which one you use, you can make different products with them. Which is why it's important to know where the alcohol group is attached. The hydroxyl group is attached, sorry. So, if we look at this diagram, it sort of simplifies it a little bit. So you can see the structural formulas here. So the primary alcohol, it's attached to just 1 carbon, which is attached to the end of a chain there, okay? This one is attached to a carbon which is attached halfway along a chain. And this one, it's actually in between 3 other chains there. So the carbon in the middle is attached to 3 other chains. So that's your primary, secondary, tertiary alcohols, which often are given the shorthand of a little 1 with a degree there, 2 with a degree, and 3 degrees. Okay, so that means primary, secondary, tertiary. So let's have a look at how we name these. First of all, we're going to look at the primary alcohols. So you'll want to pause this video. We're going to show where there's 1, 2, 3, 4, and 5 carbons in a row. And this is called a homologous series because they're all the same type of molecule, just with an increasing number of carbons, and they're all going to be primary alcohol. So the hydroxyl group will be attached to the end each time. So I want you to put the structural formula and the name of it on the right there. Okay, so you can see here that the IUPAC naming has the number of the carbon between the prefix and the suffix there. So it's between the prefix and the suffix being the end there, 4, and number of the carbon is between. Okay, and that's the IUPAC standard for naming them. Now we're going to look at when you have more than 1, or if you have, so a diol, or if you have 3, which is called a triol. And we're going to look at primary, secondary, tertiary. So this one here, we count the full length of the carbon chain. So that's 1, 2, 3, 4. We then number from the side of the functional group. So we start on this side, 1, 2, 3, 4, and that means that we have butanol. Here we're going to find the longest carbon chain again, so we're going to go all the way along. That's 4 again, so the prefix is butan. This time we're going to count from the side which will end up with the lowest numbers. So we're going to stay on this side, 1, 2, 3, 4, and that way we end up with a 2-ol. Otherwise we would have had a 3-ol, which the rules state that you have to have the lowest number possible. Okay, with this one, so the first one was a primary alcohol. Primary. This is a secondary alcohol. And the last one here, we're going to have to double check which is the longest chain. So we've got 3 long there, and you've also got 3 around the corner. So it doesn't matter which way you go there, but the fact that the hydroxyl group is on this chain here means that this is the most important chain. So we're going to start with a propan because it's 3 carbons long. We're then going to number from the side of the hydroxyl group because that's the most important group on there, the functional group. So you go 1, 2, 3. And then we count the methyl group being on the second carbon. So that's going to get attached to the front of here. So it's going to be on the 2-methyl propan. And then we say that the hydroxyl group is on the first carbon, so you say 1-ol. So it's 2-methyl propan, 1-ol. Again, that's actually a primary carbon alcohol, because it's attached to the end of the main chain there. Lastly here, we've got this attached to a carbon which has 3 other carbon chains on it, like 3 other alcohol groups. This is actually a tertiary. Now we've got to find the longest chain, which appears to be 3, depending, it doesn't matter which way you go. So we're going to call it a propan. We're going to number from, it doesn't actually matter which side because it will end up being the same here. So 1, 2, 3. And that means that the alkyl group, the methyl group here, is on the second carbon. So we're going to have a 2-methyl propan. And then the alcohol group is on the 2. So, okay, and this one's actually a, okay, next we're going to look at when you have other substituents. So this one here is a, first of all, we've got a chloro alcohol. So we number from the side of the alcohol because it's the highest priority group, and that's laid out as a rule from IUPAC. So so there's 1 and 2 there, and that is a 2 carbon chain. So every corner on this that's not labelled is a carbon. So effectively this is a carbon and this is a carbon. So the alcohol group is on the 1 and the chlorine group is on the 2. So we're going to start with 2-chloro. Okay. For the next one, we've got an alkene. So once again, we're going to start labelling from the functional group, the alcohol group. So it's going to be 1, 2, and 3. They're all carbons. And so because it's an alkene, we have to say which carbon it's between. Now it's between the 3 and the 2, so we're going to say it's the 2. It's a 2-ene. We have a 3 carbon chain, propene. The 1 carbon there, propene 1-ol. Now to show that the carbon's on the second propene, prop 2-ene 1-ol. And that shows where the alkene group is there. So for the next one, we've got a cyclohexene group. The alkene group is between the 3 and the 4, so we're going to call it the 3. So it's a cyclohex 3-ene, the 1-ol. For the next one, we've got a 2 carbon chain. It doesn't matter which way we number it. So this is what we call a diol because there's 2 alcohol groups on there. So we've got an ethan group because there's 2, 1-diol carbons there. And lastly, this is a triol. So we've got a 1, a 2 and a 3. Neither really matter which number's which, because as long as the 2's in the middle. And so we've got prop, because there's 3 carbons. Propan, 1, 2, 3. Triol. So that's a rundown of how to name these different molecules. And now you can complete the worksheet.